Good afternoon, everyone. So I'm Parvathy Nair. I'm coming from Pilani, Hyderabad campus. So I'll be talking about one of my research here in a title, Gold Cerium Oxide Modified Flexible Electrode for Enzymatic Detection of Triglyceride. So I'll give you a brief introduction of why biomarker detection is important and why it is required. So biomarkers are basically biological molecules which are present in human body, which will indicate some disease or it can indicate some response to some therapeutic intervention. So basically what we do conventionally is that we examine the human body, we collect the sample if something is wrong or as such. So sample collection can be from blood, it can be blood or urine or sweat, it can be any bodily fluids. And then we test the sample, the results are obtained, then result analysis is done, and finally the treatment is set by the doctor. So to simplify this process, now many biosensors are developed. So these are actually miniaturized sensitive rapid detection devices which can facilitate the rapid detection of biomarkers in the body. So these are the applications of biomarker detections. One is the disease diagnosis, prognosis, and monitoring. And the response to a treatment can also be understood by the biomarker concentration in the body. So it can also be used for the research and development of the therapies. And finally, it can be used for identifying the drug's mechanism of action. So coming to my topic, why triglyceride is very important. So triglyceride can lead to coronary heart disease, pancreatitis, and diabetes. So this is a pictorial representation of how triglyceride affects the blood vessel. So mild, moderate, and severe picture of that is given. And so hence, there is a need for detection of triglyceride. And on a quick note, actually, you might have seen all these levels reported on your blood test if you have gone for a lipid test. That is when you have gone for a cholesterol test. So why triglyceride is important is if you go for a cholesterol test, they not only give you the total cholesterol, but underneath you can see the HDL, LDL, VLDL levels being written. So in that, HDL and LDL can be calculated from the total cholesterol, while VLDL is indirectly calculated from the triglyceride level. So triglyceride level divided by 5 will give you the VLDL level, which is very important in calculating LDL, that is low density cholesterol level. So what I have done is I have used a screen printed electrode. So these are the fabrication method that I've used. So so for stencil preparation, I have used a PVC sheet, which is kept over a simple OHP sheet, and it is laser engraved. And finally, we pour the carbon paste and scrape the carbon ink. And finally, we get this kind of a screen printed electrode over an OHP sheet. So this is how the device is fabricated. And this is very cost-effective technique. We doesn't use any clean room technique for the fabrication of the electrodes. It is very simple technique to have a carbon-based electrode on a simple OHP sheet. So this is how the device modification is done. So on the working, so if you see here, the electrode it's a 3 electrode system. So one is the counter electrode, the middle part is the working electrode, and the one part is the counter electrode. So rightmost part is the counter electrode, the middle one is working, and where the white color is there, which is the AGHC paste, so that is the reference electrode. So on the working electrode, we have coated with gold and cerium oxide, on top of which we have coated a lipase enzyme. That enzyme is very specific to triglyceride. So that is why lipase enzyme was used. So, and then since this is an electrochemical technique, we need a potentiostator transducer to measure the signals. And finally, we get the signals and we quantify according to these signals obtained. So as you can see, this is the modification. This is the first result. So modification study, we have a bare SPC, which actually we have done a cyclic voltammetry analysis in 5 millimolar felicyanide is to 1 millimolar KCl. So this is a bare SPC, and SPC stands for screen printed carbon electrode. And we have coated with gold and cerium oxide. So you can see the electrochemical activity is getting increased due to its high surface area. And we have coated with lipase. You can see there is a sudden decrease in current, and that is due to the insulating action of any enzyme that is coated on the surface of the electrode. So that is how we determine whether the enzyme is immobilized onto the electrode or not. So these are the concentration effects. So basically, I have taken the concentration from 0.2 millimolar to 10 millimolar. So that is the range that is required to quantify the levels of triglyceride in the human body. So within that range, actually the levels of triglyceride lie in the human body. So that is the range I have chosen. And you can see that with the increase in the triglyceride level, there is an increase in current in the CV test. So we have also done a real sample analysis using blood serum, and we also have done an interference analysis. As you can see, the interference analysis, here the error is basically less than 10%. So as a summary, so these are the sets of application. As I told, it is a screen printing technique, and I have used a working electrode as a carbon paste only, reference as AgAgCl paste, and counter electrode as again a carbon paste. And this is a 3-electrode system with working electrode coated with gold and cerium oxide, and a lipase is used above it so that it is very specific to triglyceride level. And the LOD LOQ calculated is 0.25 and 0.76 millimolar, and the recovery from the blood serum is greater than 96%. Thank you.